Alright, in the previous video I explained to you, I said this sentence over here is equivalent to this sentence over here, but I just wanted to do a little bit more explanation as to why they are equivalent. So there is a suspect, and there is a sample DNA that's found in the crime scene. And both of these groups were told that this DNA is a good match. So when it says a good match, it doesn't mean it's an exact match, right? So it's a good match. And why does it say it's a good match? Because there is a tiny bit of chance that this DNA isn't actually belonging to this person. So when it's a good match, we can make two conclusions. It's that this person is guilty. So there is 99.9% chance that this person is guilty because there is 0.1% chance that the crime scene DNA isn't actually the suspect's. Okay. So there is a 0.1% chance that this person might be innocent and 99.9% chance that this person is actually guilty. Now, why this is the same as this one, the reason is because this sentence over here can actually be the reason for this. So there is 0.1% chance that this DNA doesn't actually belong to the suspect. And the reason is, if you randomly pick 1,000 people, random innocent 1,000 people, one person can actually have, and this is talking about some probability. So if you just randomly pick 1,000 people, one person in that group will actually have his DNA closely matching with the sample DNA that's found at the crime scene. So this person might be innocent, and so if you actually pick 2,000 people, then two persons from that 2,000 people will have their DNA closely matching, having a good match with the sample DNA found from the crime scene. So 1 in 1,000, because 1 in 1,000, 1 in every 1,000, you know? Pick that person, and this person will have his DNA closely matching with this. And that's the reason why there is 0.1% chance that this suspect is innocent, that this suspect's DNA isn't actually the same as the sample DNA it's found from the crime scene. So they are actually equivalent. So how are they equivalent? So we know that 1% is the same as 1 in 100. So in fraction, 1% can be written as 1 over 100. Now, so 0.1%, because it's 1/10 of that, that's the equivalent to 1 in 1,000. So that's equal to 1 over 1,000. So the systematic way of doing this is you just have to take this percentage and divide by 100. You take this one and divide by 100, and what do you get? You get 0.1 over 100, right? But you times this by 10 over 10, then you get this one, 1 over 1,000. So if you have something like 0.057%, how do you convert that into something like this? You again divide by 100, 0.057 divided by 100. You can get rid of the decimals by multiplying by 1, 2, 3, so that's 10 to the power of 3, which is 1,000. So times this by 1,000, times this by 1,000. Then you get 57 out of 100,000. Okay, so this is equivalent to 57 in 100,000, right? Therefore, for question 6, it says 0.1%. This one here is equivalent to. Obviously, these two are the same sentences, and again, as this calculation shows here, 0.1% is the same as, is equal to 1 in 1,000, so the answer is C.